press play, it starts to go. This, however, is a live show. I am going to bring us into the sky that we will see this evening, and we will talk about the visible things in that sky that tonight you may be able to go out and go see either tonight or over the next few days, depending on things like cloud coverage and that. Before we get started, just a couple of housekeeping things real quick. You have these two sets of double doors right next to the bright red exit signs. If for any reason during the show you need to take a step out, take a break, you are welcome to go through the first set of doors into that cubby area that we call the airlock. But if you exit through the second set of doors fully back into the museum halls, it will lock behind you. You will not be able to re-enter the theater, so keep that in mind. About the dome itself, it is about 4 stories high and 60 feet across, and is very reflective of light and sound. So at this time, I'm going to ask you to tuck away and turn down any phones, cameras, anything that may produce light, may produce heat. And I know that this stuff is pretty cool. I am not going to personally stop you from taking a photo. However, if you choose to do so, I'm going to ask you to make sure of 2 things. Number 1, your flash is off, and number 2, your screen brightness is down. Because if not, a couple of things happen. Number 1, you wash out the dome for yourself and everybody else. Number 2, you get a bad photo, makes it not kind of worth it. And number 3, everyone will know it was you. So, just be respectful of everybody here today. Also, because of how the acoustics of a dome work, sound can travel very easily. If I walk to right about here, I no longer have my mic on, but my voice is echoing around because of how the acoustics carry. So, even if you're having a little whispered conversation, be aware that that sound may travel, so keep yourself. But feel free to ooh and ah. Now the program does last about 25-ish minutes, so keep that in mind as well. However, in order to take a peek at the sky tonight, we actually have to make it to the sky tonight. So we have to start this show by achieving an incredible feat of time travel. We're going to watch as our beautiful sun starts to set to our right over here. And then as that happens, we are going to hit our dusk and we are going to have our beautiful night sky full of the lovely stars we will be seeing this evening. And when I say this evening, I mean that in its entirety because this is the sky from where we are in Philadelphia right now. Real quick, just to give ourselves a little bit of an orientation on where we're looking though, if the sun just set to our right, what is to our right? West, yeah. Sun sets to the west. We have our west over here, which means we have our east right there. And then we are going to have south in front of us, north behind us. The reason we are facing south is because we are in real time facing south. Makes sense, makes it easy to orient ourselves because this is where we're actually looking. Now, the thing is, if you live in Philadelphia or from another major metropolitan area, you may be familiar with something called light pollution. And that is going to be the phenomenon that due to the excessive amounts of light being emitted through cities, you dim some of the less bright stars. Which means this is close to what we would be actually seeing in Philadelphia. However, we want to be able to get a good view of all of the things in the sky. So we are going to pretend for a little bit that we are in cow country so we can have a look at all of the beautiful stuff that will still be in the sky this evening. Most of what we will be talking about this evening, or today, about this evening, will be things that are visible to the naked eye. However, there are a few things that if I have some extra special people, or people extra invested in astronomy, and you have a small telescope or binoculars, you can also check those things out. But right now, what can you see in the sky? And you can yell out answers because I cannot see hands. Stars, the Big Dipper, that's a great one. Yeah, maybe, even if you don't know it, you're looking at some planets. This over here, we're going to have part of our Milky Way visible. Again, not so much in Philadelphia. But what we are seeing is a lot more than just stars, which is where we're going to start, because that's a great place to start. And we have been looking at stars for thousands and thousands of years, and a great way that we have learned to understand them is breaking them into different types of shapes. I just heard the Big Dipper, which if you look right here a little north, a little bit behind you if you're closer to the front, we have our galactic soup spoon, the Big Dipper. Now, what do we consider the Big Dipper? What do we call those shapes that we make with our stars? Constellations. Now, if I go like this, we're going to see all of the different shapes that we have made of those stars in our sky. When we say the term constellation, though, we are actually referring to a larger sector of the sky. These shapes that we make, the lines we connect, are actually called asterisms. Whereas constellations are going to be the entire segments of stars and sky inside of those areas. And as you can see, we are having some extra light pollution this morning. Remember, flashes. All right, if we take these off, these sections not only consist of the constellation or the asterism we think about, but it's going to be the dimmer stars that we can't see. It's also going to be any nebula or star clusters that exist in there. And there's also going to be occasionally a planet passing through there. And the reason we break up the sky like this is because it makes it really easy for astronomers to then figure out where they're looking, break it down for themselves, catalog it a little bit better. However, for this show, we can interchangeably use asterisms and constellations. So we are going to be focusing on the shapes we get within those constellations. Excellent one we already talked about, Big Dipper. Now the Big Dipper is actually going to be part of the larger constellation, Ursa Major. Also known as the Bear. Bears don't have tails, so I can't tell you why that's there. But it is going to be the Big Dipper, part of Ursa Major. And that is going to be one of the most recognizable constellations that will be in our spring, summertime sky. But there's definitely going to be a lot of other things that we can use to help us find more interesting stuff. So when we are talking about our sky, not only do we break it up into those segments, we also break it up into hemispheres. On Earth, we have this invisible line that separates the north and the south. What is that called? Equator, yeah. We also have a celestial equator, where we have our northern constellations and our southern constellations. And then we have this band right here. This is going to be the celestial equator, and it is going to be the line on which our planets orbit. So whenever we see a planet in the sky, they're always going to be following this same path, going through this sector of sky, just depending on the season and where it's landing. But I bet you can also likely, a decent amount of you, can name all of the constellations that do not currently have their artwork. Because they're going to be a specific portion of the sky. And do I have any astrology fans in the room? I guess not. But guess what? This is going to be your zodiac. The zodiac band is going to be our celestial equator. Which also means we can use the zodiac constellations to find any planets that may be visible in the sky tonight. So let's talk about some a very important and very visible zodiac that we're going to talk about, and that is going to be Leo. Leo is going to be very prominent in our sky. It is going to be one of the largest, or will have one of the brightest stars that we will see this evening. And that is going to be by his front little paw area in his neck. That is going to be the star Regulus. And again, Regulus is going to be very, very prominent. So if you can find it, you will then know that you have Leo. And not only that, it can also help us to spot, before we lose them for the rest of the season, our Geminis. So our Gemini twins are going to be behind us in the north, falling right almost beneath that dawn sky. But we have the twins in the shoulders, and those are going to be the stars Pollux and Castor. And I just like to point these out because it is Gemini season, so it's nice to still be able to get a chance to spot those stars. And now, the last thing, as I mentioned, is that because of where the zodiac lands, we can use it to find some other things. So for instance, You can utilize Regulus right now to find a very nice planet. It's our neighbor, it's the red one. What is it? Mars. Yeah, if I fade down Regulus, Mars is sitting right on top of it. And the fun thing about planets is you can find an easy way to differentiate them from stars when they're in the sky, because stars twinkle. They will have that little bit of in and out glow, whereas planets are going to be stark and prominent through the sky through that entire night. And on a good day, if you have not a whole lot of light coming off of the moon and you're in a fairly residential area, you can even see how Mars has that little tinge of orange to it. It appears that orange color, but it is going to be very visible and right in there with Regulus this evening. And this is the sky as of 10:20 this evening as well, just to give you an idea. But we have Mars, we have Leo, we have the Gemini twins, we have the Big Dipper. This is a lot of what we were seeing in the west, so how about we now take a trip to the right? Because while we have not quite hit summer yet, we are coming into the season where we're going to start seeing the constellations of our summer triangle. So over here, we are going to have Cygnus, which is going to be the swan, and that is going to be one of the first constellations comprising our summer constellation. See the third one, it hasn't quite risen above the horizon yet. But when we were talking about Cygnus, this is also going to have quite a few very bright stars in it. That is going to be Albedo in the beak of the swan, and then Deneb in the tail of the swan. Two very prominent ones, Deneb being what is included in the summer triangle. Now, apart from just stars, I mentioned that you can also sometimes see things like nebula and star clusters. Cygnus is going to be home to a very cool nebula. It is the remnant of a supernova star, and it is going to be called the Veil Nebula, also part of the Cygnus Ring, and it exists right around this area. Now, it is one of the things that you will not be able to see in great quality with a naked eye if you have a telescope or binoculars. However, thanks to the technology that's been developed over the years, we can also use infrared imaging to take a peek at that nebula a little closer. This is going to be part of the Ring of Cygnus, or the Veil Nebula. And the colors that we are seeing is just the way that we can differentiate the different gases that were left over from that star, how we can tell them apart. So we're going to bring that back down. And now, second one we're going to talk about is going to be the constellation Lyra, part 2 of our summer triangle. And Lyra is also going to be known as the Lyre. And at the top, we have a super bright star that is going to be the star Vega. Vega is going to be very prominent. When you're looking for the summer triangle, that is probably an easy one to start with, though the shape of Cygnus also makes that pretty identifiable. Along with the Veil Nebula and Cygnus, Lyra is also going to be home of another really cool nebula called the Ring Nebula. And the Ring Nebula is going to also be the result of a supernova star. And if we bring that up, you'll get to see, again, we're ionizing that gas. I love the Ring Nebula because it kind of looks like a portal into a new world when we're seeing it like this. But those nebula are just the portions of the sky where there is remnants of those stars that have gone up. So we're going to bring that down. And then, while I'm not going to talk too much about our last summer constellation coming in, just because again, we haven't gotten to that season, we are also going to have Altar. So if we have Altar, we have Vega, and we have Deneb, we are going to have that summer triangle. Now, one more constellation I want to talk about is going to be the constellation Ophiuchus. Ophiuchus is also going to be the bearer of the serpent. So if we bring up the artwork, would be holding a serpent. It is just another constellation around him. But this is Ophiuchus, and he is going to have the very bright star Russellhawk, neighboring that summer triangle. And the reason I like to bring up Ophiuchus is because, once again, there's some other stuff that, if you have a telescope or binoculars, you can see a little bit better, and that is not a nebula. That is instead going to be a star cluster. It is going to be it is going to be a type of globular cluster, which is a lot of stars condensed into a small space. Now, this is a globular cluster found in Hercules, but it is very, very similar. So if you were to have an infrared imaging telescope, have an imaging closer of that globular cluster, that star cluster, it would look like this. Very condensed, very compacted with a lot of beautiful stars. So, with that said, that is going to be a lot of the stuff that we are seeing comprising our stars. But there's also, like we said, planets, nebulas, and there are going to be some more things that move around in the sky that you maybe just are not necessarily super tuned into, but they are still there all the time. What do you think I have moving around us right now? Okay, so these are going to be satellites. Now, we are going to have a lot of stuff circling Earth. This is 100 of the brightest satellites, and then a little bit more of something called the stationary orbit. But if we could see all of the satellites and all of the things that are man-made surrounding our Earth, we could possibly go a little crazy. That's a lot of stuff. Though I think it would be worth getting a little bit of a better view. So, you won't see this in the sky tonight, I don't think. But just a greater scale of what we're looking at right here. We have a lot flying around the Earth right now. And apart from just being satellites that are in there to catalog things about space, these are also going to be the things that give us our cell signal, give us GPS location, that track our weather patterns. The geostationary orbit is going to be home for a lot of this technology we need that tracks our planet and gives us our electronic devices and how they work. But I think since we are talking about man-made satellites, it also makes sense to take a peek at our one natural satellite, which is what? The moon, yeah. So let us take a quick trip to the moon. Now today, we are operating with a waning gibbous moon. That is the phase we are in today, which means we are going to have about 72% light visibility on our moon. Our next full moon is our next new moon is going to be on the 25th. We just passed our strawberry moon, our full moon, that was on the 11th. But we have a third quarter on the 18th and a new moon on the 25th, if you like following those moon phases. When we talk about moon phases, though, we are talking about the light reflecting off of the moon from the sun. So if we just give the moon a little spin, we can see as it comes to a full moon before it starts waxing, we start to lose it, we are then at a half, and then we have a quarter crescent, and then a new moon, and then we do it again. It is just how much light we are getting reflected off of the sun's surface. And our moon is going to be pretty far away. However, obviously it's not as far as we can go, so since we're talking about the sun's light, I think it would be fair that we traveled to the sun a little bit. And a little bit farther, because our sun is going to be 93 million miles away. It's very, very far. And the cool thing about the sun is that it is going to be 99% of the mass of our solar system. We have a lot going on in our solar system, obviously, but stars are going to be comprised of a lot of gas, a lot of energy. So this is going to be more than majority of our mass. It essentially is the mass of our solar system. We are all taking up one whole bunch of other stuff. But you also may notice that we have these little spots right there. Those are going to be sunspots. And the cool thing about this image is it is a real-time look at the sun activity on its surface. So these sunspots are these sunspots that we have on the sun right now. Sunspots are just going to be where it's a little bit of that gas being released, a little bit of pressure being released, so they appear a little bit darker because they're actually a little bit cooler. But it's also going to be where you can just have freight trains of plasma being what creates the sun, streaming off and giving us those solar flares that we can sometimes get. So, since we are looking at the center of our solar system, I do think it would be nice to kind of see, based on the perspective we're at, where those constellations are landing. If you'll notice, they are all, perspective-wise, still very similar. We're looking at different ones, obviously. Our Big Dipper has moved over here, but the perspective, their shapes are still the same. That's while being at the center of our solar system. We all probably know that we are not at the center of the galaxy, so I think it's worth zooming out a little bit to see if that perspective shifts. What's going to happen now, we're going to start to take a trip a little bit further out. We're going to watch as our planets start to fade away. And we're going to go and look at our home, there's us, but from a larger scale. We have Earth, we have Mars, this is where we would have our asteroid belt before we get to our outer gas planets. But we're going to go so far out, we are going to look at our universe, our galaxy in its entirety. And the reason I like to do this is because it'll give us a kind of depth, a kind of relative idea of the vastness of space. We have already zoomed out so far that we are just a speck, and still all of our constellations are sitting where they were before. But the further out we go, the potential that has to change. So I would say buckle up, because we're going to move a little bit faster in just a second. Welcome home, just at a little bit larger of a scale. What we're looking at is the Milky Way, the giant Beyblade in the sky, our lovely galaxy. But when you are looking around this galaxy right now and you're seeing some other stuff in the sky, those aren't just going to be things like stars, those are going to be other galaxies. Ones that could be similar to ours, we just don't necessarily know yet. However, this little speck right here, that little specky dot, that's us. That is where we live in our galaxy, in one of the Orion arms, considered the suburbs of our galaxy. The center being a black hole that we are hundreds of years away from. Now, I love this because it part just giving us the idea of the vastness of space. I do literally mean it when I call it home because billions of years ago, before we existed, we were out here. We were part of the ether of the universe. We are ephemeral beings made from internal substance. The elements that we are comprised are the result of stars going supernova. So you are more connected to all of this than you may even realize. And the cool thing is, we are still learning about just how close we are. Because if we get a little bit closer to that dot is not just our location in the galaxy. It is also going to be all of the points from our constellations, from those asterisms. Those are the different lines we created, but now reaching out into different points of the sky. Because the stars that are in our solar system, the stars that we see, reach farther out than we may even realize. As we get a little bit closer, you're going to see a kind of red ball start to appear. That is called the radiosphere. And the radiosphere is as far as our radio signals have reached out in the last 100 years. That is as far as we got. We have still so much further to go and so much more to learn. Because if we just bring up Ursa Major again, there are going to be stars outside of that sphere. Well, the ones comprising the Big Dipper, which are the most visible, are going to be the ones a little closer. But the reason a lot of stars sometimes are so dim that we can't see them, even though they're there, is because they stretch so far out into space. And all of these stars are emitting so much light. And again, the sun is the brightest thing in our solar system. It is our star, but these stars are emitting light significantly more than our sun, just reaching all the way back to where we are on Earth. But speaking of Earth, we've kind of left the realm in terms of the things that we can see while looking at our sky tonight. So I think it only makes sense that we head home a little bit so that we can just kind of remind ourselves of what we will be able to have visible this evening when you go out into the evening night and take a peek. Well, we're going to start to zoom in. We're going to come back and we are going to find our lovely home in our galaxy, our lovely solar system. We can see as those constellations flatten back out, returning to the perspective that we had them at before. You can see our sun is getting ever so much closer. And what we are going to do is we are going to fly home. We are going to return to our lovely planet amongst all of these other planets, all of these other stars, in order to remind us of what we can observe and what we can appreciate in our sky this evening. And we are back at Philadelphia at 10:20 this evening. When we look at our sky, so long as you are facing the south, to your west, you are going to have right on the horizon Pollux and Castor, our twins from Gemini season, which you can find to the help of Regulus, the foot of the lion, our lovely Leo constellation, with Mars sitting right on top of Regulus. You get a 2-for-1 deal with this guy. You come up a little bit, you find the Big Dipper. If you look at the sky, this will probably be the easiest thing for you to spot. And you can know if you follow the edge of that dipper down, you'll meet Regulus and you'll meet Mars. We jump to the other side of the sky. We are going to have Vega, which is going to be that bright star of the constellation Lyra. Which, in Lyra, if you have, again, a telescope, take a peek, see if you can find that beautiful ring nebula. Next over, we are going to have our stars of Cygnus. We are going to have Albereau in the peak and Deneb in the back. Deneb and Vega making up our summer triangle, with Altar part of the constellation of Aquila, which we didn't quite talk about much. And then also in Cygnus, right in the center, you can maybe potentially spot that Veiled Nebula again with some binoculars or a telescope. And then if we jump to Rosselhog, the star right here, that is going to be paralleling Vega and part of the larger constellation Ophiuchus, which if you can find, you may also be able to find down in the lower portion of the constellation, that globular cluster M10, which is going to be that super concentrated bit of stars. And if you were lucky enough to see a little bit of our Milky Way up and out there, if you have a beautiful darkness sky. But one more thing to do before we go is we have to time travel one more time. We need to create the dawn of a new day in the same day. We are going to have our sun start to rise to our east and return us tomorrow at about 7 a.m. Congratulations. You made it to tomorrow. But with that, that is the sky tonight. Thank you so much for joining us. I'm going to ask that you exit through the doors on the left as the next